Welcome to Dystopian Bot Rise. Today, we reveal the startling industrial journey of toothpaste, transforming raw bones into daily hygiene. We start our day with this minty paste, but few realize its creation involves a complex mix of biology and chemistry. The journey begins unexpectedly at the slaughterhouse, where animal bones are collected not for soup, but for their mineral content. Workers meticulously clean these skeletal remains, stripping away organic matter to prepare the dense calcium structures for intense thermal treatment. The clean bones enter giant kilns where temperatures soar, effectively burning away all organic impurities and leaving only minerals behind. Under this intense heat, the biological structure collapses, transforming the bone into fragile white ash composed almost entirely of calcium. Heavy crushers pulverize the brittle remains into a fine dust, creating calcium carbonate, the primary abrasive agent in your toothpaste. These microscopic particles act like sandpaper for your teeth, physically scrubbing away plaque and stains without damaging the enamel surface. Without this abrasive component derived from bones, brushing would be ineffective at removing the sticky bacterial film that causes decay. The finished powder is bagged and tested for purity, ensuring no organic contaminants remain before it heads to the mixing facility. Leaving the bone processing plant, we enter the realm of chemistry, where synthetic ingredients are prepared to enhance oral health. The most critical chemical addition is fluoride, a mineral that reinforces tooth enamel and makes it resistant to acid attacks. Scientists carefully measure this potent ingredient, as precise dosage is vital for safety while providing maximum protection against cavities. To prevent the paste from drying out, manufacturers add sorbitol, a sweetener that also acts as a humectant, holding moisture. Sodium lauryl sulfate is introduced to create the satisfying foam that helps spread the cleaning agents into tight gaps between teeth. Binders like xanthan gum are essential to thicken the liquid, giving the toothpaste that distinct structure that sits on your brush. Flavoring agents, typically mint or peppermint oils, are concentrated to mask the bitter taste of the cleaning chemicals and minerals. Titanium dioxide is often added to give the paste a bright white appearance, associating the product with cleanliness and purity. With all components prepared, abrasives from bones and chemicals from the lab, we are ready for the massive industrial mixing phase. We move to the main production floor, where giant stainless steel tanks await to combine these ingredients on a massive scale. Liquid ingredients like water and sorbitol are pumped in first, creating a fluid base for the powders that will follow. The bone powder is gradually added to the liquid, ensuring it disperses evenly without forming clumps in the massive mixture. Powerful blades rotate to blend the slurry, but simply mixing is not enough. The process requires a controlled environment to succeed. The entire mixing process happens under a vacuum to remove air bubbles that would otherwise spoil the texture and volume. If air were left inside, the tube would be half empty and the paste would oxidize, ruining the product's shelf life. Temperature is strictly controlled during mixing to ensure the binders set correctly, creating the perfect viscosity for the final product. After hours of blending, the abrasive bone powder and chemical agents have unified into a smooth, homogeneous, and stable paste. Before packaging, a sample is extracted for immediate testing to ensure the batch meets the strict viscosity and pH standards. The paste must be thick enough to sit on a brush, but fluid enough to squeeze out of the tube easily. Once approved, powerful pumps transfer the dense paste through sanitary pipelines into holding tanks, ready for the high-speed filling lines. We now enter the packaging zone, a marvel of automation where raw materials become the retail product recognized by consumers. The tubes start as flat sheets of laminate, which are rolled into cylinders and welded at the seam with extreme precision. High-speed blades slice the continuous tube into individual lengths, preparing them to receive the plastic shoulder and cap assembly. The shoulder of the tube is fused to the body, creating a robust seal that can withstand the pressure of squeezing. Caps are screwed on immediately to keep the interior sterile, but the bottom of the tube remains open for filling. Surprisingly, toothpaste tubes are filled from the bottom. The empty tubes are inverted and placed into a rotating filling carousel. Precision nozzles descend into the tubes, filling them from the cap upwards to ensure no air pockets are trapped inside. The paste is injected with millimetric accuracy, ensuring every tube contains exactly the weight promised on the packaging label. Immediately after filling, heated jaws clamp down on the open end, melting the plastic to create a permanent airtight seal. Simultaneously, a laser or embosser marks the crimped edge with the batch code and expiration date for tracking and safety. Trimmers cut away the excess plastic from the seal, giving the tube its familiar neat appearance before it leaves the filler. The filled and sealed tubes slide down a chute, joining a conveyor belt that leads them to the final cartoning machine. Flat cardboard blanks are snapped open by mechanical arms, creating the boxes that will protect the flexible tubes during shipping. In a synchronized motion, the tube and a folded instruction leaflet are pushed into the box before the flaps close. Glue is applied to the flaps, sealing the package. The product is now fully assembled, but the process is not over. Automated checkweighers scan every single box. Any unit that is even slightly underweight is instantly rejected from the production line. Robotic arms stack the individual boxes into larger shipping cartons, preparing them for palletizing and distribution to warehouses globally. While production continues, the quality control team performs rigorous tests on random samples to guarantee safety and effectiveness for consumers. Microbiological tests are crucial. Samples are incubated to prove that no harmful bacteria or pathogens are present in the batch. Chemists verify the fluoride concentration again. Too little is ineffective, while too much can be hazardous to human health. Abrasion tests simulate months of brushing to ensure the calcium particles clean the teeth without scratching or damaging the enamel surface. Even the packaging is tested. The boxes must withstand crushing forces to ensure the product arrives at the store intact. Once cleared by the lab, the pallets are moved to massive warehouses, waiting to be shipped to retailers around the world. Trucks carry these products from the factory gates, bridging the gap between industrial manufacturing and your personal bathroom cabinet. On the supermarket shelf, it sits among dozens of options, hiding the complex story of its origin from the consumer. When you open the box at home, you are holding the result of global mining, chemical synthesis, and precision engineering. That simple act of brushing connects you to the slaughterhouse bones and the chemical labs we explored earlier today. From raw animal bones to the minty fresh paste, this supply chain is a testament to human ingenuity and resourcefulness. The result is a product that protects our health, boosts our confidence, and has become indispensable to modern civilization. It's a marvel of chemistry and logistics packed into a humble tube that costs just a few dollars. As the factory lights dim, the machines rest briefly, preparing to produce millions more tubes for the growing global population. This web of supply chains connects industries across continents, proving that even simple products require a complex global effort. Next time you squeeze that tube, remember the fire, the chemistry, and the engineering that made that moment possible. We have traveled from the raw organic reality of bone processing to the sterile, minty perfection of the final product. Behind every automated machine are the scientists and workers who ensure quality and safety in every single batch produced. It's a product designed to be used up and washed away, yet its impact on our health is permanent. Even the empty tube has a story, as modern manufacturers strive to make packaging recyclable to reduce the environmental footprint. From whitening gels to sensitivity pastes, the basic process remains the same, anchored in the science we explored today. The synchronization of these machines is a dance of efficiency, maximizing output while minimizing waste in a competitive market. Hygiene is the foundation of health, and this industry provides the tools necessary for billions of people to stay healthy. Science continues to evolve, finding new ways to improve these formulas, making them safer, more effective, and more sustainable. Ultimately, the goal is simple: to preserve the human smile for a lifetime, protecting it from the wear of time. We hope this deep dive into industrial manufacturing has changed the way you look at your morning routine forever. If you enjoyed this breakdown of everyday engineering, please like this video and share it with your curious friends. Thank you for watching this industrial journey. Subscribe to Dystopian Bot Rise for more revelations about the products you use daily.